Today we're doing objective 9. We're going to evaluate and identify functions. Okay. We do have a discussion for this objective. With this, first we want to talk about, what a function is. In words, we can say a function is a set of ordered pairs in which no two ordered pairs have the same first coordinate. All right, so if we look at an ordinate pair, we know that an ordinate pair is x, y, right? So that means that no two ordered pairs can have the same first coordinate, which is the x. So let's look at some examples. First, very important thing that I want y'all to understand is that x term, this is the input, the y is the output. All right, because in this objective, remember, we're going to be evaluating functions as well. So I want you guys to understand the parts of the ordered pair and how they kind of, relate as far as a function. So a function is a set of ordered pairs, right? So with the ordered pairs, all of the x's, that's the input, and all of the y's is the output. All of the x's can also be called the domain, and all of the y's can also be called the range. Okay, so I'm gonna give y'all an example. This is example 1. So we got 1, 2, we got 2, 4, we got 3, 6, and we got 4, 8. So we got 1, 2, 3, 4 ordered pairs in this set. Remember, these are our set brackets. This is how we, put something in the set. We just talked about this in objective 8 with our set builder notation. So we have 4 ordered pairs in a set. So now we need to figure out what the domain and the range is. So I just told y'all that the domain is the x's, or the input, and the range is the y's, or the output. Okay, so the domain is 1, 2, 3, and 4. Does that make sense how that works? And the range is 2, 4, 6, and 8. Okay, so when you are putting these numbers in the set, you want to make sure you put them in order from least to greatest, and you want to make sure you have your set brackets. These. For example 2, we have -1, 0, 0, 0, 1, 0, 2, 0, and 3, 0. -1, 0, 1, 2, and 3. That is correct. And for the range, all you have to do is put 1, 0. All right. Another cool thing about writing numbers in a set, you have to write them in order from least to greatest. And if that number appears more than one time, you don't have to write it over and over again. All right. So that's the awesome thing about writing numbers in the set. So the next thing that we're going to talk about is a relation. And this is basically just a definition. A relation is any set of ordered pairs. And a function is a type of relation. Okay. So that's the basic thing that you need to know about a relation. A function is a type of relation. So now we're going to look at, we see the definition of a function. A function is a set of ordered pairs in which no two ordered pairs have the same first coordinate, which means they don't have the same input or the same domain. So let's look at what that actually looks like. So in our domain set, let's say we got 2, 4, 6, and 10, and in our range set, let's say we got 3, 6, and 8. Okay, so we have the ordered pair 2, 3, 4, 6, 6, 8, and 10, 6. Okay? So remember, a function is a set of ordered pairs in which no two ordered pairs have the same first coordinate. All right? So if we look at our domain, no two pairs have the same first coordinate, right? We got what we got? 2, 3, 4, 6, 6, 8, and 10, 8. So 6, 8, and 10, 8, they have the same range, the same second coordinate, but none of these have the same first coordinate. So this is a function because it meets our definition, and when we kind of draw it like this, we can see clearly what the definition is saying. So let's look at another example. All right, in this example, we got 0, 1, and 2 in our domain set. And in our range, we got -2, -1, 0, 1, and 2. All right. So we got 0, 0. Let me just write them over here so y'all can see them. We got 0, 0. We got 1, -1. We got 1, 1. We got 2, -2. We got 2, 2. All right. So let's look back at our definition of a function. A function is a set of ordered pairs in which no two ordered pairs have the same first coordinate. So if we look at our coordinates here, we see that these two have the same first coordinate. We got 1, -1, and 1, 1. And these two have the same first coordinate. We got 2, -2, and 2, 2. If we look at it like this, the lines coming from our domain, you see we have 2 lines coming from 1 and 2 lines coming from 2. So according to our definition of a function, this can't be a function because we have more than one ordered pair that they are sharing that first coordinate. They're sharing that x term. So this is not a function. Okay, so this is a quick, easy way to figure it out, to draw one of these diagrams so that you can clearly see how your coordinates are paired. You can also just write your coordinates out like this. If that domain term is repeating, then we got a problem. It's not a function, okay? As we move on and we start graphing functions, there's also ways to tell if it's a function by looking at the graph. So we'll, of course, talk about that more when we start graphing functions. The next part of objective 9, which I feel like is the easiest part, we're going to be evaluating functions, right? So y'all know how to identify a function. So now we're just going to evaluate some functions. And like you guys said, we're taking, what they gave us and we just plugging it in to the function and we just simplifying it, okay? So let's look at some of those examples. So let's look at S of t equals negative 16t squared plus 64t plus 4. Okay? So, another thing about functions. When you see functions, they will be written like this. This is S of t. All right? So, typically you'll see f of x, which looks like this, equals, whatever the function is. This particular one is S of t. So what this means is basically S is our function and t is the variable that we're plugging into S. So wherever we see a t, we're going to plug in whatever they give us. So for this particular question, they tell us that t equals 1.5. So this is one of the ones where I will pull out my calculator, because y'all might not want to be doing this by hand or in your head. But this example is basically just to show you guys, how this works. So let's take a step back. Let's look at f of x equals x squared. Okay, so this is a basic function. If I tell you that x equals, let's say 2. If I say evaluate f of x equals x squared for x equals 2, all you have to do is plug the 2 in. So f of 2 equals 2 squared. And you keep it going. 2 squared equals 4. Okay? So that's basically what we're doing if you are, confused as to where we're going with this. So for this particular problem, and we can just call this, this can be example 1. For this particular problem, wherever we see a t, we're going to plug in 1.5. So your next step will look like negative 16 times 1.5 squared plus 64 times 1.5 plus 4. So after you plug this in, I really, really need y'all to pay attention, okay? A lot of people mess this up, and I don't want that to be y'all. So, you see how we have negative 16 times 1.5, which is squared. You have to do this part. You have to do this part first, okay? If you multiply that negative 16 times that 1.5 and then square it, I promise you it will be absolutely wrong. Please do not do that, okay? I beg of you. Please do not. So you have to do the exponent first, all right? You want to square it first. And my marker that went out. So you want to square it first. Please square it first, okay? Like I said, I beg you to do that. So after you square it, and over here, it's just going to be, you could just plug in 1.5 in for t. That's going to be the same. This just symbolizes that this is what you plugged in for t. So our next line will be negative 16 times 2.25, which is 1.5 squared. Then we have, let's just bring this on down. Let's work out each step. Okay. So we did our exponent first. Now we're going to do our multiplication next. So negative 16 times 2.25, we get negative 36. Okay. Bring our plus sign down. Then we have 64 times 1.5. That is 96. Then we bring that plus 4 on down, okay? Then now it's all left to do is to just add these up. And of course you can put that in your calculator and you should get 64, okay? So you may get some decimals. Of course you could just put that in the calculator, what we call, plug and chug. Just plug it in the calculator and work it out. So this is the gist. This is the same stuff we've been doing. We just doing it for functions now, okay? So let's look at another one. For example, 2, we're going to evaluate g of t equals 3t squared minus 5t plus 1 when t equals negative 2. All right, easy peasy. They done gave us the t. All we got to do is just plug the t in. So we plugging in negative 2 for t. So we got g of negative 2. And wherever we see a t, we're going to put that number in parentheses. Now, I recommend whatever you plug in that you put it in parentheses. If it's a positive number, a negative number, whatever it is, when you plug it in, put it in parentheses, okay? So now, this is where we are. This negative 2 is squared. We have to do that first. So negative 2 squared is 4. Then we multiply it by the 3 and we get 12. Okay? So this is what, while you're working the problems out, this is what your thought process needs to be. Then you need to look here. We got minus 5 times negative 2, which is the same thing as negative 5 times negative 2, which is positive 10. Okay? Then we have plus 1. We could just bring that plus 1 down. Now we have something that's so simple we can do in our head. The hardest part is going from here to here. Remembering how to calculate this properly. Remembering how to multiply, add, and subtract integers. All right? Everything we did in the previous objectives, now we're putting that all together and we doing some good math, okay? So 12 plus 10 plus 1, that's 23. That's easy, right? But if we would have messed this up, it all would have been wrong. If we would have messed this up and put a negative number, negative 10 or something, it all would have been wrong, okay? So when I say these problems can be tedious, this is what I mean. You want to make sure that you're working carefully and that you're paying attention, okay? So remember I told you guys that, with the functions, I told you that the x and the y, the X is the input, and the Y is the output. So in this particular problem, when T is -2, the output is 23. So if we had to write this as an ordered pair, it would be -2, 23. So I really want you guys to understand how this is working. When we start graphing functions, you may get a function like this and they say, hey, graph it. So you have to decide some X's, or in this case, some T's that you want to put in to evaluate so that you can get your output. Of course, whatever you put in for T, that's going to be your input, which is your domain, which is the first term of your ordered pair. And your output is like your Y. It's going to be the range. It's going to be the second term of your ordered pair. So please don't think of this as different things. It's all the same stuff, okay? All the same stuff, just maybe a different way of looking at it and using it, okay? So please grasp and understand this, because we're going to need it when we start graphing functions, when we start putting in the input to get an output. That's basically, evaluating. All right. So let's keep on going. So what if you're asked to evaluate with a whole nother function? So let's look at that. So we got to evaluate P of Z. P of Z is 3Z minus 7, but Z equals 3 plus H. So now we're not just plugging in a number for the variable, we're plugging in basically a whole nother function for the variable. All right. So let's explore how to do that. So for your P of Z, wherever you see a Z, you're going to plug in this whole thing. So this is another reason why I asked you guys, whatever you substitute in to put in parentheses, whether it's a positive number, a negative number, or this whole thing. We got 3 plus H. So we're going to plug in 3 plus H wherever we see a Z. So we got 3 times 3 plus H. We put it in parentheses. If we don't put this in parentheses, we might not understand that this is going to require the distributive property. So whatever you plug in, I beg of you, please put it, the whole thing, whatever you plug it in, put it in parentheses, okay? Then we're just going to bring down the minus 7. So that's our next step. And when we fully simplify it even more, we're going to combine the like terms, which will be 9 minus 7. So our final answer will be 3H plus 2. Basically, when you write these out, you want to write them in order from by the degree, and I'm not really going to get into that a lot, but this has a degree of 2, this has a degree of 1, and this has a degree of 0. So this will be typically how the order that you see things written. So while 2 plus 3H is not, that's right, but the way that we write it in we call it in descending order. So this has a degree of 1 and this has a degree of 0, if that makes sense. But if you did 2 plus 3h, I wouldn't necessarily count it wrong because we haven't really went into degree and all that, okay? All right, so for number 4, we got P of R equals 5R cubed minus 6R minus 2. And it says find P of -3, okay? So in this one, it don't say P equals -3. They say find P of -3. You have to know that it's the same thing, all right? Like I said, we're not doing stuff that's completely different. It's just used in a different way or something. All right, for example 5, we got Q of R equals 2R plus 5 when R equals H plus 3. All right. So these are the two we're about to work on now. All right. So -3 cubed is -27 times 5. We get -135. We get -135. -6 times -3 is +18. Then we bring that -2 down. So our final answer will be -119. Look at example 5. We got 2R plus 5 when R is H plus 3. So remember, where R is, we're going to plug in H plus 3. Plug the whole thing, and we want to put it in parentheses so we can clearly see what we need to do, which is the distributive property. All right? So we have to multiply the 2 times the H and by the 3. So we got 2 times H, which is 2H. We got 2 times 3, which is plus 6. And we bring our plus 5 down. From here, we have to fully simplify, all right? We got to combine like terms. So our final answer will be 2H plus 11, all right? If you need more work, then you need to be reaching out to me to set up an appointment during the office hours so that we can make sure that you do not get behind, as all of these objectives are building on top of each other. All right, the next thing that we doing in objective 10, you need to know how to do this, okay?